Hi, this is Dr. Schulman. This is Math for Teachers. For passing that elementary school praxis exam, and we're doing still that part 1A. I just broke it into two parts, and then when I was doing multiplying, dividing, I got kind of tired yesterday. So here we go. I'm going to finish doing all the different ways you can show your students how to multiply and divide. There's fractions here, there's decimals here, there's algorithms, there's area displays, pretty much everything you need. So I'm going to share my screen. If you want to follow along with me here, where I'm doing all the problems, this is where I'm at. So we're doing numbers and operations, natural, whole numbers, and rational numbers. That's pretty much what's going to be. I added in the decimals and fractions just to make it a little bit stronger. So notice algorithms and stratagem modeling for adding and subtracting. That was the first one I did. And then, as you can see, it's no strategies, models, and problem situations for multiplying and dividing. But where are these in general? Just if you want to see it. I don't know why, but we're doing multiplying and dividing. I guess it's just not being my friend. That's okay, right? Trying to show you everything on the side of how I got here. So I'm just going to reload the page. Here we go. And I'm going to combine these because most of the stuff you need, whether you're doing the algebra or the geometry, the only difference is going to be one of the courses is going to focus on all the algebra components. One is going to be all the geometry components. But I want you to be able to pass that exam. So that's why you're going to get to see everything. So here we go. There was your introduction. We did all of the curriculum stuff. We're in the very beginning of instruction. And the first ones is right here, which is numbers and operations. And I really want to show you all of them. So we got a lot to go through, but this is the first one. And I've shown you all the steps and how to do it. A was for multiplying, dividing. Yes. All right, cool. So this is where I am. Then I'll do B through G. But I just want to make sure you see every possible way, whether it's a word problem, using an area, we use the number line a lot. They're showing you area ways to multiply here, as well as the algorithm. So let's get into it. So we made it up to here, which is multiplying an algorithm with 3 by 3. I'll start with this one again. So here we go. This is using the carrying method, not using the area method like it should before. So it's 905 multiplied by 467. 7 times 5 is 35, so we carry the 3. 7 times 0 is 0 plus 3 is 3. And 7 times 9 is 63. And now we use the 3, we use the 7. So let's keep going. All right, now we have to hold the 0 because it's not times 6, it's times 60. All right, 6 times 5 is 30, so we carry the 3. 6 times 0 is 0, plus 3 is still 3, so we're not actually having one that we're holding up here. And then finally, 6 times 9 is going to be 54. All right, cool. So we use the 3, we use the 6. So now we're multiplying everything times 4, but it's not really 4, it's 400. And that's why we have to hold the 0 here. So there's 0, 0. Now it's 400. All right, 4 times 5 is 20. So carry the 2. 4 times 0 is 0, plus 2 is 6. And finally, 4 times 9 is 36. So we multiplied everything. Now our just step is to add. 5 plus 0 is 5. We didn't carry anything. 3 plus 0 is 3. 3 plus 3 is 6. We didn't carry anything. I didn't put a little 0 here, but that's okay. If you want to go back, you can. Oh, I went back too far. If you want to put the little zeros up there, you can. All right. Now 6 plus 4 is 10, plus 6 is 16, so we carry the 1. 6 plus 5 is 11, plus 1 is 12, carry the 1. And finally, our final answer is 3 plus 1 is 4. So we have 426,635. And I made a mistake. 6 plus 4 is 10, plus 6 is 16. Where was the mistake? I guess I multiplied it wrong. That's okay. Let's do one more. We all make mistakes, right? 203, 856. 6 and 3 is 18. Carry the 1. 6 times 0, 0 plus 1 is 7. And that's nothing left over. And then it's 6 times 2 is 12. All right. I didn't cross those out, but I'll survive. So now we're timesing it by 50. 5 times 3 is 15. Carry the 1. 5 times 0, 0 plus 1 is 6. And then we have 5 times 2, which is 10. All right, now we're not timesing it by 8, we're timesing it by 800. 8 times 3 is 24, so we need a 2 there. 8 times 0, 0 plus 2 is 10, so we need a 0, carry the 1. And 8 times 2 is 16, plus 1 is 17. So I think I did this right. That's 8. That's 12, so I want to carry the 1. This is 10, 12, 13, carry the 1. This is 2. This is 8. And this is 1. So I keep making mistakes somewhere. So I missed one term. That's a shame. Well, not coming off to a good start. Might as well try it one more time. Let's 685. I'm sure I'm making one stupid mistake every time. 958. All right, let's get after it. 8 times 5 is 40. Cool. 8 times 8 is 64, plus 4 is 68. 8 times 6 is 48. 48 plus 6 is 54. 8 times 6 is 48. 48 plus 6 is 54. I'll do the little crosses out. Maybe that'll help. All right, 0, hold the place. 5 times 5 is 25. Carry the 2. 5 times 8 is 40. 40 plus 2 is 42. 5 times 6 is 30. 30 plus 4 is 34. All right, now we're just looking at the 9. More 900. 9 times 5 is 45. Carry the 4. 9 times 8 is 72. 72 plus 4, 76. And 9 times 7, oh, sorry, 9 times 6. I think I was multiplying the top. 9 times 6 is 54. 54 plus 7. Just so I don't make another mistake. 61. Let's see if I did this one right. There's just a lot here, a lot of places to make a mistake. That's 10, that's 12. That's 10, that's 16. That's 3, 4, 5. And that's 6. So let's see. Yay! Cool. I guess crossing out did help and being really precise. We all make mistakes, right? All right, let's keep it going. So that was the algorithm. And now we're going to do the same algorithm, but with decimals. And then we're going to do word problems, and then we've got scientific notation. So let's keep going. All the different ways we can show multiplication. So this is for decimals for students, and all of these are going to be really helpful. I'm just going to pause this 1 second. All right, we are back in it. Here we go, sharing the screen. All right, so I always show students decimals this way, 8.5 times 6. I really have them think of it as 85 times 6. And then whatever answer we have, one decimal place, one decimal place. That doesn't work for every student, but that's okay. Let's see how it goes. 6 times 5 is 30. So we put the 0 here. We hold the 3. And then do 6 times 8 is 48. 48 plus 3 is 51. So we got 51. And then we have to move the decimal one place. So this is going to be 51 instead of 5/10 because there's one decimal place. So 8.5 is 1/10 of it. So 8.5 times 6 is 1/10 of 85 times 6. So we move the decimal to the place one time. And that should be our answer. Let's see. Yay. Well, they show it the same way that I do it, which is good. I think this is easier than the area way. Okay, so we're in let's go with the not guided version of this. So let's try it. Okay, 9 times 8 is 72. 9 times 5 is 45. And 45 plus 7 is 2. 35, sorry. 45 plus 7 is 12, and so it's 52. So it's 522 next. Oh, they like to cross these out. Oh, we just move the decimal because there's only one. So here's one decimal point, 2, 3. Decimal point goes here. One place, two place, three places. And that's how you do it. Whoa, sorry, that got all crazy. All right, let's try another problem. So now we're doing a 2 by 2 guided. So we're going to move decimal place. I would think of this as 75 times 34. Then we move decimal twice. So that's 20. 0. Have the 2 there. 4 times 7 is 28. 28 plus 2 is 30. So there's the 30. All right, so we use the 2 and the 4. 3 represents 30 in this case, even though if we don't have the decimals there. So here we go. 0, 15. We put the 5 here. I'm the 1 here to hold it. 3 times 7 is 21. Then we add 1, which makes it 22. And we add up, so it's 0, 0. That's 5, 0, because there's no extra place. 3 plus 2 is 5. And we have 2. Now, finally, we have to move it over. So this is 1/10 of this one. So 7.5 times 34 is 1/10 of 75 times 34. But we want to move it twice. So 7.5 is 1/10, 75 is 1/10. So we move the decimal one time to the left. So, oh, they're doing it one step at a time. So the first one is 255. Then we're going to have to do this again. All right. So we have the 255, and now we're doing the other side because this is 1/10 of the other piece. So we're going to move it one more time. So our final answer is going to be 25.5. See, look, we go once, twice. Oh, well, 25.5. Yeah, that's the right answer. We did it. Yay. All right, so let's do another one. So this is without the steps, then we do 3 by 3. 9 times 8 is 2, carry the 7. 9 times 9 is 81. 81 plus 7 is 88. We have 0 here. 3 times 8 is 24. Carry the 2. 3 times 9 is 27. 27 plus 2 is 29. That's 2. That's 12. That's 18. And that is 3. And we have 1, 2 decimals, so I have to go 2 decimal places. 38.22 should be the final answer. Yes. Ta-da. All right, and then we can go to 3 by 3s before we change it all up. So here we go, is the crazy 3 by 3 one. So I do 3 times 854 and then move it 3 decimals, but this is what we're gonna do. So 20, 0, carry the 2, 20 again. 22 plus 20 plus 2 is 22. So 2, carry the 2. We got 20 again. Plus 2 is 22. That's the first one. We got to cross these friends out. We're going to do the same thing. The 5 represents 50. So 0. 5 times 5 is 25. We got the 5. Carry the 2. 5 times 5 is 25. Add the 2. There's 27. There's a 7. We got to carry the 2. 5 times 5 is 25. Carry the 2. Cool. And now we finally have to do this not for 8, but for 800. So here we go. Next, we have the 0 zeros. 8 times 5 is 40. It's another 0. Carry the 4. 8 times 5 is 40. Plus 4 is 44. 8 times 5 is 40. Plus 4 is 44. So we have 0. 7. 9. What? 9. 11 plus 2 is 13. That's 7. I know. 7. And then 4. All right, so 8.54 is 1/1000th of this because we were going through decimal places. So this is 1/1000th of the pattern. So we got to move it 3 times to the left. So we know it's 1, 2, 3. So it's 473.970. We did it all right. Wasn't that exciting? Okay, cool. All right, so now we're going to do one on our own, and we're finally done with the algorithm. So we have a decimal here and then 3 here, so it's going to be 4 in the answer choice. 40 plus 2 is 42. 5 times 7 is 35, plus 4 is 39. So we used all these. All right, so now we're going to go with 70. 7 times 5 is 35. 7 times 8 is 56, plus 3 is 59. You get confused, just check yourself. I like to just make sure that I'm not saying the wrong thing after doing so many in a row. All right, so 56 plus 3 is 59. And then we have 7 times 7, which is 49 plus 5. 49 plus 5 is 54. So we use this 7, we use these 2, and now we get to use the final term, which is not 7. We're going to pretend it's 700. 7 times 5 is 35. Carry the 3. 7 times 8 is 56. Plus 3 is 59. And 7 times 7 is 49. 49 plus 5. 49 plus 5 is 54. Oh, it should be the same because this is the same digits. Nice. So we just add 5, 7, 18 plus 5 is 23. 7 and 9 is 16. 16 plus 2 is 18. That's 10. And finally, we have 6. 1, 2, 3, 4 decimals. 1, 2, 3, 4. So it's 60.8375 should be the final answer. And we got it. Sweet, sweet, sweet. All right. Time to look at some different types of problems. So we've got some distribution that we're looking at. So which one's not the same? All right. So how about 100 plus 20? What's another way of writing it? Well, 10 times 10 plus 2, that's 100 plus 20. So it's not the first one. All right, let's do 10 times 10 plus 10. Well, that's 100 plus 100. Okay, this is already not right. Let's check the other ones. The next one is 5 times 20 plus 4. This is 100 plus 20. This one works. And 2 times 50 plus 10. That is 100, and that's 20. All right, so the only one that doesn't work is this one. Which one is not equivalent? We did it. Sweet. Beautiful. All right, let's go back. See what's next. All right, let's multiply and divide some fractions. Reduce it fully. So I'll show you a bunch of ways to do this. 2 times 5 times 1 times 4. 2 times 1 is 2. 5 times 4 is 20. And we can simplify this by dividing both by 2. Get the answer of 1/10. What's another way we can do it? 2 over 5 times 1 over 4. You could immediately cross out a bottom and a top by extending this. 2 goes into 4 1/2. 1 times 1 is 1. 5 times 2 is 10. Either way, it's 1/10 or 0.1 or 10%. Those are the 3 ways we can write the answer. They want it as a simplified fraction. There we go. Magic. Let's see if they give us a division one. Here's division one. Cool. Same idea, right? All right, so division. 7 over 8 divided by 7 over 3. The best way to do this is to multiply by the reciprocal. So this is going to be 7 over 8 times 3 over 7, which we know is going to be 21 over 56. And we can divide these both by 7. We know the real answer is going to be 3/8. What's a faster way to see this? Once you flip it, top and bottoms can cancel. 3/8. So whenever you're doing this work, when you are working with the fractions and you want to divide, you multiply by the reciprocal. 3/8 is the answer. We got it. We got it. Ta-da. They showed the same steps. All right, now we get some mixed numbers. Multiplying and dividing. Cool. So here we go. 6 4/5 times 1/4. You multiply the bottom, you add the top. So that's 34/5 times 1 over 4. So it's 34 over 20. Divide by 2. And you get 17 over 10. Now we could cross these out right away, make that a 2, and make that 17, and you see it's 17 over 10. But that's not how they want the answer. So what do we have to do? We have to take it and we have to divide this. This goes into 1 time, and what's left over? 1 and 7/10 is your answer. Then I'll do a division 1 as well. Nice. Beautiful. Is there a division? Here we go. So we have a division. So 1 and 7/9 divided by 3/4. So we multiply the bottom, we add the top. 9 plus 7, so this is really 16/9 divided by 3/4. And here's where we have to do some moves. So we just have to remember that this is the same thing as multiplying by the reciprocal. So it's 16 over 9 times 4/3. It'd be much easier if it was multiplied, so we can do some canceling already, but we can't. So what's the best way to think about this? 9 times 3 is 27. And 4 times 6 is 24. Carry the 2. 4 times 1 is 4. Plus 2 is 64 over 27. And I don't think we can simplify it. So how many times does 27 go into 64? I believe it's 1 time. No, it's probably 2 times, right? Well, what's 27 times 2? That's 14, 54. Yeah, it is 2 times. So 27 goes into 64 2 times. That's 54 with 10 left over. So it's 2 and 10 27ths. Let's see if that's the right answer. 2 and 10 27ths. We did it. That took a lot of steps, was real hard. We got the same answer. Look at that magic. Okay. Let's do some word problems. These are other ways you'll definitely be seeing them. So Juliet is making bows. Each bow is made from a piece of ribbon. Okay, so she's making bows, right? Pretty bows. Each bow is from a ribbon that is 3/5 yards long. How much ribbon will it take to make 15 bows? So if it's 3/5, I want 15 of them, right? We have to multiply 3/5 times 15, cancel the bottom and the top. We need 9 bows. To solve, we'll need to multiply 3/5 by 15, because we know the size of the groups and the number of groups, the size of the groups and the total yard, the size of groups and the number of groups. We don't know I'm pretty sure this is the reason. We don't know the total yards of the ribbon. Nice. Oh, they didn't actually multiply? Okay, well, whatever. They want to know why. I guess the reason's more important, so it's 9. Cool. I'm assuming level 2 will actually have to solve one. All right, let's do it. Now our teacher is pouring paint containers. Pouring paint. So we're pouring paint. I always like drawing pictures, even though if I'm bad at it, into containers. So we're pouring the paint into containers that each hold 1/5 of a gallon, 1/5 of a gallon. How many gallons of paint should they buy if they need to fill 19 containers? Oh, so it's just going to be 1/5. 1/5 times 19. This is also, you can make it fresh by putting a 1 under it. So we have 19 over 5. And they want this as a mixed number. So 5 goes into 19. How many times? 3 times with what left over? 4. So 3 and 4/5. So I would say you have to buy 4. I'd buy 4. But they want this as a mixed number. So 3 and 4/5. I would say you need it by 5. That's me. Yep. Because, like, how do you buy 4/5 of a gallon of paint, right? You just need another gallon. So I would actually say this is wrong. And I would tell my students that you need a fourth gallon to buy. Because who sells a 4/5 of a gallon, right? All right, let's keep going. All right, let's see what these are. So we've got integer multiplication in context. Okay, so in the 1960s, NASA designed a rocket, the Sea Dragon, to be launched from underwater. The rocket was never built, but let's imagine it was. At some point, the rocket rises and hits sea level elevation. That's when we start our stopwatch. Oh, give me one moment. And we'll pause this. All right, let's get back into it. And let's see some more of these multiplication division problems. So here's a way to another word problem. Word problems are important. All these ones we were doing before, without the context, I feel like they're so hard for students. I know it helps giving them the area displays. I know it helps giving them the algorithm. But I think word problems that let you draw these pictures. So I think that's going to be like the most helpful for you. Okay, so let's try this one. So in the 1960s, NASA designed a rocket, the Sea Dragon, to be launched from underwater. The rocket was never built, but let's imagine it was. So we have a rocket. Here's my rocket, the Sea Dragon. At some point, the rocket rises. Some point, the rocket rises. It hits elevation 0. That's when we start our stopwatch. Okay, so once it hits sea level, we start our stopwatch. And that's your sea level, the sea. And then we start our stopwatch. Let's assume that the rocket's elevation is changing at a rate of 35 meters per second. All right. That rate is positive. Let's assume that the first seconds the rocket elevation is changing at a rate of 35 meters. The rate is positive because the rocket is rising. All right, so we're going up after sea level, 35 meters per second. That's positive, and then I'm assuming it's going to fall. Okay. Use the orange scroll bar to explore the rocket. Okay. Woo! Ours looks just like their picture. Cool. So every second it goes another 35 meters. Nice. So at time 0, we should be at 0. At time 1, we went 35 meters. Time 2, we went another 35 meters. That's why we're at 70. At time 3, we went another 35 meters. That's why we're at 3 times 35 is 105. Okay, let's do it. Move the orange scroll 3 seconds. Oh, well, that was fun. Use the times button or the keyboard to write multiplication. So it's 3 times 35. So we know that equals 105. Oh, okay. Did they just want it without the answer? Okay. They want it without the answers. That's 105. All right, so now we're gonna go 8 seconds. All right, 8 seconds is 8 times 35. This is your x-axis. There's your y-axis for your Cartesian coordinates. So remember Descartes, and we're at 280. And positive time equals positive. All right. Now imagine that the rocket is returning to Earth. So I knew we'd have to go down eventually. Um, landing in the ocean. This time we start a stopwatch when it hits the sea. Let's assume the first second after it hits the water, the change -30. The rate is negative because the rocket is falling. So now we're going back down. It hit the sea. We're going down, 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 down. Cool. So if we want to go 6 seconds, I was close of what they were going to ask us to do. So it's 6 times -35, which is -180. What? Oh, it's 30. Sorry. It's going slower as it's descending, which is fine. So that's -180. And then let's do 3 seconds. 3 seconds, it's -90. 3 times -90. Oh, sorry. 3 times -30, which is -90. -90 meters. Or we've gone 90 meters, but we're -90 meters. So positive times negative equals negative. So this is trying to show them that positive times positive equals positive. Positive times negative equals negative. Negative times positive equals negative. And finally, negative times negative equals positive. So that's what they're trying to show the students using graphs. When the rocket rises, the change in elevation is positive. Multiplying the seconds by positive results in a positive. Positive times positive is positive. When the rocket falls, the change in elevation is negative. Multiplying the seconds, which are positive, results in a negative elevation. Positive times negative is in fact negative. Are you sure? I think I'm sure. Yeah, we did it. It's a great problem. All right, so let's do another one. All right, so we have the sea dragon. Well, let's do a different one. Oh, they're all sea dragons? All right, let's do it. At some point the rocket rises, hits sea level. That's when we start stopwatch. Let's assume that the first seconds, is this the same type of problem? Oh no, it's different. All right, let's do it. All right, let's assume that the first seconds the rocket elevation, this rate is positive because the rocket is rising. Nice. We moved it. We want 8 seconds. It's 8 times 35. We're at 280. That's why the x-axis is usually called input versus output. Remember, we don't start the stopwatch right away. We only start it when the rocket hits sea level. So reading a time of 5 seconds represents the second since we left, the second since the stopwatch began. All right, how would we represent 5 seconds before we start our stopwatch while still underwater? Really would be -5. So a reading of -2, the 2 would represent 2 seconds before the stopwatch began. Oh, nice. This is cool. So we have the negative and we've got the oh, that's why we can do negative and times positive. I like it. Cool. All right, so move it to -5. So 5 seconds before. So -5 times 35, which is way underground. And now we want to do -2 seconds. So it's -2 times 35. So what's the rocket 2 seconds before the start? It's -70 meters. So 70 meters below sea level. Multiplying a negative by a positive results in negative elevation. Negative times positive equals negative. All right, now imagine the rocket is returning to Earth. The rocket's elevation is changing -40. This rate is negative because the rocket is falling. All right. Remember one way to think about the time stopwatch. So we can think of 4 seconds before we start stopwatch. Second since the rocket, second since the rocket was launched, second since the stopwatch began, seconds before the stopwatch. Yeah, I believe that's what it is. Nice. So we've got negative and negative. Cool. So let's go -4 seconds before we click the stopwatch. This is a -4 times -40. So two negatives make a positive. So we're at 160 meters. Very interesting. Let's go to -5. Come on. Here we go. -5 times -40 is going to be a positive 200. So multiplying negative by a negative results in a positive elevation. All right, let's answer the crazy one. So negative time is the time before the stopwatch has started. When the rocket rises, the change in its elevation is positive. Multiplying a negative by a positive results in a negative elevation. Negative times positive is negative. When the rocket's falling, the change of elevation is negative. Multiplying a negative time by negative results in a positive elevation. So negative times negative is positive. Really good questions. This would be great for students. So you've got the words, you've got the graph, you've got why it works. I like it a lot. All right, let's keep on going. Multiplication tables. Ooh, let's see how good our time is. 63, 24, 24, 36, 21, 12, 10, 81, 6, 54. Oh, I missed one. I want to go to 10. So sorry. 8 times 7 is 56, 15, 40, 24, 6, 18, 40, 16, 16, 6. We did it. Ooh, what a time. What a time. I like it. All right. So multiplying and dividing integers. Let's see what we got. Oh, so here's another one. So now we have negative. So negative times positive is negative. This is going to be a -9. -16. Two negatives make a positive. -9. Positive 20. -32. -5. -27. -10. -8. Oh, I already went too far. Okay. So these are just helpful for showing students like ways that they can practice. All right, so here we go. Here's some division, a very simple one. 1/2 divided by 6/5 is the same thing as 1/2 times 5/6. We know it's going to be 5/12. We did it. There's no simplification you needed to. 5/12. Magic does not simplify. Let's do a harder one. All right, so here we have 2/3 times 1/2. You can literally cross these out and get 1/3. The other way is 2 times 1 is 2, 3 times 2 is 6. Divide both by 2, we get 1/3. Magic. 1/3. All right. Okay, so let's do the area model again. All right, so here's the area model. Enter the missing values to find 4 times 6/2. So I usually use this way to do it. I multiply the bottom, I add the top. So I have 4/1 times 12, 13 halves. And I would cancel this. So our answer should be 26. That's the way I do it. So, but that's using the algorithm. So let's use the area. So improper fractions or mixed numbers. To enter the mixed number, the model used the space and the slash key. So this should be 4 times 6 is 24, I believe, and 4 times 1/2 is 2. According to this above, 4 times 6/2 24, right? And 2. So it's just 26. There is no mixed number. I'm going with 26. Okay, cool. Okay, so 6 times 4 is 24. 4 times 1/2 is 2. Nice. We did it. I like it. Let's do one more of these. 6 times 5 is 30. 6 times 1/2 is 5. 30 plus 5 is 35. It's weird none of them have the mixed numbers. What? Did I make a mistake? Let's just see the question again. Oh yeah, because 6 times 1/5 is now 5. I did 30, so this is 6/5. So it's 31 and 1/5. Let's do one more of these. Nice. All right. Let's do one more of these. All right. All right. Ooh, now it's division. I love it. So 2 times 11. And then it's 2 times what is 3/4? I believe it would have to be 3/4 plus 3/4, so 6/4. Let's think about this. 2 times what equals 3/4, right? So the best way to do it, if this is x, we actually have to divide both sides by 2. So x, because if I divide by 2, those cancel. Okay. There's a little algebra. So 3/4 divided by 2 is the same thing as 3/4 times 1/2, because we flip it. That's 3/8 is the answer. Not 6/4, 3/8. And we can always check this to make sure. 2 times 3/8 equals 6/8, which simplifies to 3/4. We did it. So it's 11 and 3/8. What a good problem. Magic. All right, let's do it one more. 9 times 6 is 54. 9 times 5 is 45/6. All right, so, but when I have 45/6, we could simplify that. 45/6. 6 goes into 45 how many times? So you can't go into 4, but 6 can go into 40 times 7. 6 times 7 is 42 with 3 left over. So that's 7 and 3/6. Or we know it's the same thing as 7 and 1/2. Plus 3/6 is 1/2. So if I have 54, I got to add 7 more to it. 61 and 1/2 should be the answer. Let's see if I got it. So you can try these. These were nice and tough. I'm glad they're getting harder. Nice, 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 nice. Cool. All right, let's keep it going. Now I got fractions and mixed numbers with integers. So this one's -3 and 7/10. times negative 1 3/4. So the first thing you got to tell your students is, guess what? Two negatives, they make a positive, right? So we multiply the bottom, we add the top. So this is 37/10 times, multiply the bottom, add the top. So that is 4 plus 3 is 7/4. And I'm going to simplify. Oh, I can't. Craziness. So I have 40 on the bottom, and 37 times 7 is 9, carry the 4. 21 plus 4 is 259/40. But they want this as a mixed number, so 40 goes into 259 how many times? Well, I just think about this as a little bit simpler, right? So 4 can't go into 2, 4 can't go into 25. So when you're teaching your students how to divide, have them estimate. Have them think about how many times is 4. When does 4 make a 25? Well, we can go 4, 8, 12, 16, 24, 28. So it's this one. This is the one we want. 4 times 6. So 4 times 6 is 24. 40 times 6 is 240. And what's left over? Well, 259 minus 240 is going to be 19. 6 and 19, 259s. What a crazy problem. What a crazy problem. Oh, I got 259/40. I like it. We got 6 and 19. Oh, it's 40s are on the bottom. Ugh, my bad. 40 still stays on the bottom. Well, that was a simple mistake. But that's okay, right? We all make mistakes. Let's do one more new problem. All right. So we know this is going to be a negative answer because it's a negative times a positive. So 1 2/5 times 3 3/5. We multiply the bottom, we add the top. So that's 7/5 times 3 times 5 is 15. 15 plus 3 is 18/5. Can't simplify. So I got a 25 on the bottom. 7 times 8 is 56. 7 times 1 is 7 plus 5 is 12. So we're here again. I'm not going to forget that 25 is on the bottom. So I'm going to put it right there. All right. So 25 goes into 126. 25 can't go into 1, can't go into 12, 126. I'm going to go times 4. It's actually times 5. 5/4 is $1.25 with 1 left over. So our final answer is -5 and 1/25. Practice some more of these if they're hard for you, okay? All right, let's keep going. Here's some easy one-step multiplications for when we get to algebra. So we have 7y equals 42. Divide both sides by 7. Y gives us the 6. So we just have to do the opposite to get it. We could check it. 6 times 7 is 42. All right, let's see a level 2. -10 equals -10t. Divide both sides by -10. A negative divided by a negative is a +1 equals t. All right. So now we have some crazier division. Oh, scientific notation. All right, so I knew these would get tough. this is probably a 5th grade standard, I think, or a 6th grade standard. So it's 4.4 times 10 squared. And they want the product, so we got to multiply 3.2 times 10 to the 4th. What I always do with these is I first multiply these. I'll show you how I do them. So I would do 44 times 32. 2 times 4 is 8. 4 times 2 is 8, so that's 88. Now it's not times 3, it's times 30. 3 times 4 is 12, carry the 1. 3 times 4 is 12, carry the 1, that's 13. So we're left with 1,320. 1320. And we already have these together. So we're starting with this 10 to the 6. But this is in scientific notation, okay? This is scientific notation always has to have one number with the decimal. So here we go. Let's go 1, 2, 3. It's 3 times bigger. All right. So we know it's going to be 1.32 times 10, not to the 6. We need 3 more, 10 to the 9th. I believe this is the answer. 1.32 times 10 to the 9th. Let's see if I did it right. Oh, did I multiply it wrong? 4.4, 3.2, 14.8. Oh my God, I multiplied wrong. 4.4 times 3.2. Oh, I didn't move the decimal in the answer and I got it wrong. Oh, that's annoying. So here's my first mistake. 4 times 4.4 times 3.2. So let's do the first mistake. I never moved it. So there's 8. That's 8. 0. That's 12. That's 12 plus 1, which is 13. So now I didn't even add these like a fool. Okay. So there's 8. That's 0. That's 1. That's 1408. And then I have 2 decimal places. So I have to move this 2 spaces. So it's really 14.08 times 10 to the 6th. And then we have to move it over 1 decimal place. So it's 1.408 times 10 to the 7th. It's because I messed this piece up, right? Yeah, let's do another one. All right. So here we go. I got 5.4 times, oh, sorry, 5.4. I don't know why it's slowly moving. That's so weird. All right, times 10 to the 6th multiplied by 1.4 times 10 to the 4th. I'm not gonna make the same mistake. So the first thing I do is 5.4 times 1.4. We really look at it as 54 times 14. 16, carry the 1, 21. 0, because it's not 1, it's 10, 4, 5. So our answer is going to be 6, 5, 756. All right. However, I have 2 decimals, 1 decimal, 2 decimals. So it's really 7.56 times 10, and what 6 plus 4 is 10. Now, if this was any bigger, I'd change it. So I might as well show you one more of these. 7.56 times 10 to the 10th. Didn't have me move it up 1. Yeah. All right. Let's hopefully they give me a harder one. Okay, let's see. 1.152 times 10 to the 6th. 6.4 times 10 squared. This looks so weird. Okay, this one looks challenging. So it's 1152 times 64. 4 times 2 is 8. 4 times 5 is 20. Carry the 2. That's 4 plus 2 is 6. 4 times 1 is 4. Now it's not times 6, it's times 60. 6 times 2 is 12. Carry the 1. 6 times 5 is 30 plus 1 is 31. Carry the 3. 6 times 1 is 6. Plus 1 is 9. And then there's your 6. So we're left with 8, 2, 7, 13. So 7, 3, 7, 2, 6. I have 1, 2, 3, 4. 1, 2, 3, 4. Oh, I was hoping it didn't do this again, but that's okay. So 7.3728 times 10 to the what's 2 plus 6 is 8. I was trying to have one that had an extra piece here, so we have to move it up a space. But what can you do? It's just the way the cookie crumbles. 3, 7, 2, 8 times 10 to the 10. If this was 73, right? And when we worked it out, we'd have to move it one more place. It'd be 10 to the 9th. But our answer is 10 to the 8th. What? Did I multiply wrong? Oh, it says quotient. It's division? All right. I'm just going to go back and divide this. So let's go to the question. I multiplied it. So let's do division. What is the quotient of 1.152 times 10 to the 6th over, I'm sure I did it right, it was multiplied, 6.4 times 10 squared. Well, 10 to the 6th and 10 squared, that's 10 to the 4th. And let's do this multiplication, this division. So this is the big number. It gets to go where? Inside the house. So I want to make this a whole number. So then I have to move this one place. So there's our decimal. We have a dot here. 64 can't go into 1. 64 can't go into 11. 64 can go into 115, I believe, twice, because 64 times 2 is 120. No, it's just once. So minus 64, that's a 1. 11 minus 6 is 51, so it's 512. How many times does 64 go into 512? Let's see. 64 times, what is it? Is it times 3? That's 2, carry the 1. 6 times 3 is 18, 192. So it's not that. So we just need 64 to 512. What if it's, so the good way to think about it is 6 times what gives you 50, right? 6 times 5 is 30. Nope. 6 times 7 is 42. 6 times 8 is 48. And 6 times 9 is 54. So it's going to be this one. So it's going to be the 6 times 8, which is should be 48. I don't know why I wrote a 50. So there it is. So it's 48. So 64 times 8. 8 times 4 is 32. Carry the 1. 48 plus 1 is 49. 492. That's a 0. And we're left with the 20 remainder. So I bring down the 0. 64 can't go into 200 evenly. All right, so this one I'm just getting wrong. Let's see what it really is. The first part, 1.152 divided by 6.4. It's just 0.18. That's what I had. How come it didn't work out? Oh, I guess when I multiplied, I messed up. That's annoying. So I guess it is 512 and I just messed up my subtraction or something crazy. So we're left with 0.18. I'll have to do another one. And then we have 10 to the 6th and 10 to the 4th. So this is what we have right now, 10 to the 4th. But we need this decimal here. We got to move it one place. So if I want to make this bigger, it's got to be 1.8 times, if I'm moving it back, it's one smaller. So times 10 to the 3rd. That should be the answer. And I gotta do one more of these. See if this is right. I guess my division was just weird. So let's do another one with division. New problem. Quotient. Cool. Here we go. We got 3.515 times 10 to the eighth divided by 4.75 times 10 to the fifth. So right away, 8 minus 5. I have 10 eighths. I have 8 tens and 5 tens. It's going to leave me with 3 tens at the end. Now we have to do the division part, which I'm not going to mess up. 3.515. And then we have 4.75. So we have to move this 2 places to make it 475. So this gets moved 2 places. So we know it's going to be, there's our decimal. 475 can't go into 3. 475 can't go into 35. 475 can't go into 351. So we have to think about 475 times what number is going to give me this. I'm going to go with 7. Let's see if this works. 7 times 5 is 35. Carry the 3. 49 plus 3 is 52. 7 times 5 is 28. 7 times 4 is 28. 28 plus 5. 28 plus 5 is 23. Oh, we're too small. We are too small. We can get bigger than that. So let's do times 9. So that's 45. 9 times 7 is 63 plus 4 is 67. 9 times 4 is 36 plus 6 is, and now we're too big. Crazy. 475 times 7. 475 times 9. Okay. 475 times 8. So it is 475 times 7? All right, I'm not going to argue with it. That's the closest we get. Oh, it's 3. I forgot to carry the 3. 3, 3, 2, 5. So it is 7. 3, 3, 2, 5. We subtract this. 5 minus 5 is 0. And that's your 9. 190. And then we have a 0 here. So 475 times what should give us 1900? 475 times, I don't know. Is it times 4? Let's see. 4 times 5 is 20, carry the 2. 4 times 7 is 28, plus 1 is 29. 4 times 4 is 16, plus 2 is 1890. All right. So I got 100. I got 10, so I have 100 left over. So 0.475 or 0.47. So let's do the whole thing. 3 clear. So 3.515, right? I'm just checking. Oh, clear. 3 point, oh man, come on. 3.51515 divided by 4.75. You just have to make the decimals match. 0.74. I don't know why I was off by 10, but guess what? That's pretty close. I was slightly off yet again. Maybe I should be less messy. So we got 0.74 times 10 to the third, but we want to move it over one place. So it's 7.4 times 10. It's one smaller times 10 squared. That should be your answer. I would practice these. You could see I tripped up a little bit. We all make mistakes. but ta-da. It's not like it's being rounded. It should be perfect. I was off by what? 10, right? I'll survive. Now let's try another one. Okay. What value of y makes this equation equal? All right. So here's a typical algebra problem you might get for your students. This would be way better with context. So the first step is we're going to subtract 2 on both sides. So have your students have the steps given. The opposite of addition is subtraction, or you can just have them subtract 2, but they really need to know the reason. It's because it's the opposite. And then we're going to divide by 3. They don't know the properties yet. Just get them really used to saying what they're doing to understand why they're doing what they're doing. And then we can just say QED as it's been demonstrated. You can also have your students plug in 5 times 3 is 15 plus 2 is 17. All right, let's do a harder one. Oh, that one is way harder. So let's look at one that's a little bit tougher. So we have 5/4 x minus 1/2 equals 85/8. So the best thing I would do is I'd make a little table because the students might get confused, right? There's fractions here. There's all this crazy stuff, right? So let's go to given. And then we have our, oh, sorry. Oh, it's loading. So these are our steps. And these are our reasons. And the first thing is always given to us. So if I'm looking at this thing, right? I even lost my equal sign somehow. The furthest thing from my x is this 5/4. So I have to divide by 5/4, but that's so weird, right? Dividing by this, like if I were to divide both sides by 5/4, I'm already feeling like this is strange. So the first thing I want to do is actually multiply by the reciprocal. I don't really have the room to show you the whole thing, so I'm just going to show you how I would do it. But notice that you should be doing the steps for your students. So 5/4 times x minus 1/2 equals 85/8. So the first thing I'm going to do, instead of dividing, which is weird, I'm going to multiply by the reciprocal or the flip. Doing this is going to help me out a lot. Cancels, cancels, and I'm just left with x minus 1/2. Now, instead of multiplying this number and multiplying this number, making them really big and scary, like 40 on the bottom, this is a giant number on top, right? It would look like this, right? If I don't cheat. So there's 40, and then 4 times 5 is 20, carry the 2. 4 times 8 is 32, plus this is 360. Then you got to simplify. 36 divided by 4 is 9. Like that's so much, right? So the faster way is you're like, okay, 4 goes into 8 twice. Nice. 5 goes into this, right? How many times? 5 goes into 5 once. Sorry, 5 goes into 85 how many times? Well, 5 goes into 8 one time, and 5 goes into 35 7 times. So I got 17 halves. Did I do it wrong the first time? I think 5 times 17 is 85. Yeah, okay. And 85 times 4 is not 360. That was the problem. It's 340. 340, 17 halves. Perfect. So 340 over 40 is, we divide this by 2 and we get 17 halves. So either way, you're going to get 17 over 2. And your last step is all you have to do is add the 1/2 to both. 17 halves plus 1/2 equals 18 halves. And what is 18 halves really? 9, positive 9. We did it. We did it. That looks scary. All right. So here's some divisibility rules. All right. Without dividing, determine if 96090 is divisible by 6 and explain how you know. I'm going to go with no. It isn't. It last two digits. Oh, these are the rules. All right. I forgot the one for, I know the one for 3 and 9. Some of its digits are not divisible by 9. That doesn't help. It does not end in a 9. I think it's not divisible by both 2 and 3. Its last two digits are not divisible by 3. I don't think this is, I think this is the reason. So I guess it is because its last two digits, it's divisible. The sum of its, I would say, it's divisible by both 2 and 3. I'm going with that. I'm going with it. Nice. So here are the rules. 2 if it's even. Nice, I like it. If the sum is divisible by 3, I know that one. If the last two digits are divisible by 4, it ends in a 0 to 5. If it's sum and divisible, it's up by 9. And the sixth rule is if it's divisible by both 2 and 3. Wow. I did not know that rule, but now I know. Let's do another one. It's divisible by 2. It isn't because it's not even. Nice. These are good rules. Now let's do another one. Is divisible by 4? Yes, because the last two are divisible by 4. I believe that was the rule it said. I didn't know this one. Nice. All right, let's do one more. Divisible by 6. 8. Oh, it's not because it's not divisible by both 2 and 3. Nice. So I would definitely remember these rules. They're super important. I didn't know the 6 one. I just knew the 2, the 3, the 5, and the 9. I didn't know the 4 rule. I didn't know the 6 rule. Now I know. All right, here's a one-step equation for division. B over 9 equals -10. So we're going to multiply both sides by 9. The opposite of dividing by 9 is multiplying by 9. So B equals -90. Ta-da! All right, we got 3 to go. Ooh, unit fractions. 21 divided by 3 is 7. Cool. 16 divided by 8 is 2. What? Oh, what else? It's this one. Okay. 5 divided by 25 is the same thing as 5 divided by 1/2. No, it's the other way. It's 1/5. Okay, 18 divided by 1/5. The same thing as multiplying by 2. So that's 36. Same thing as multiplying by 3. So it's 12 times 3. Oh, no, it's opposite. Oh, all right. 30 divided by 3 is the same thing as 30 times 1/3. This is 18 times 6. No, 18 divided by 6 is 3. 50 divided by 2 is the same thing as 50 times 1/2. 90 divided by 10, that's just 9. 27 divided by 3, 27, that's the same thing as times 1/3. 21 divided by 3 is the same thing as times 1/3. 5 divided by 50 is the same thing as 5. It's 1/10, so it's not 1/5 times 50. It is 1/5 times. No, it's 50 divided by 1/5. Yes. Oh, okay. I'm not struggling. 21 divided by 1/3. 21 over 3. It's 7. So no, it's divided by 1/3, so it's times 3. There we go. 15 divided by 5 is 3. So it's the same thing as multiplying by the fraction. Same thing as multiplying by 8. So it's 80 times 8. Wait, no, it's not. 80 times 1/8 divided by 1/8 is the same thing as multiplied by the reciprocal. Okay. 2 divided by 90 is 1/45. 70 times 1/2 is the same thing as dividing by 2. Or just the answer. 28 divided by 4 is 7. Or same thing as multiplying by 1/4. 15 divided by 1/3 is the same thing as timesing by 3, 45. 35 divided by the same thing is the same thing as multiplying by 1/7, which is 5. 14 divided is the same as 14 times 2, which is 28. And the last one, 18 divided by 16 is 1/8 times 16. 16 divided by 1/8, no. 18 divided by 16 is the same thing as 8/16. Nice. Whew. So try it yourself. These were tough. I don't know why. I guess because they had unit fractions. So we finally get another one, a tape diagram. So here we go. 2 2/3 divided by 1/3. The way that I would do it would be 2 2/3 times 3, because I flipped it over. 2 times 3 is 6, so it's 8/3 times 3/1. What is 24 divided by 3? 24 divided by 3, 8, 16, 24. It's 8. I'm going with just with 8. The model below represents the division. This is 2 2/3 cut into 1/3. So it's 1, 2, 3, 4, 5, 6, 7, 8. Nice. Oh, this is very useful. I like that a lot. Let's do a new one. So 2 1/3 divided by 2/3. You can go this way, but since you have the tape, we literally have 2 2/3 cut. So we have 1, 2, 3, 4, 5, 6, 7. Your answer is 7. What? Oh, it's how many groups of 2/3? Oh, one group, two groups, 3 1/3. Or sorry, 3 1/2. 3 1/2 of that. All right, let's try another one. I want to do it not my way, their way. All right, so 1/3. These are all 1/3 each. 1, 2, 3, 4. This one's just 4. All right, let's try another one. All right, so this is 1, 2. So this is 3 2/5. So that's 1, 2, 3, 4, 5, 6, 7, 8 1/2. What an interesting way to show it. I think that's great. And let's do one more. 1, 2, 3, 4, 5, 6, 7 halves. So 7 1/2 makes up 3 1/2. That looks beautiful. I think it is better than my way, but you got to draw it. And we got 2 left. All right, so which is this? So going backwards. So this is, I believe, 1 1/2. So it's, I believe, 1 1/2, 1 2/3, 1 2/3 divided by 2/3. And we're left with 2 1/2. 1/3 divided by 2/3 is 2 1/2. Nice. All right, so now we have 3 2/3 divided by 1/3 equals 11. Might as well do one more. All right, so now it's 2 3/5 divided by 3/5 equals 1, 2, 3, 4 1/3. Yeah, there it is. All right, and here's the last one. So greatest common factor, least common multiple. We're gonna spend a whole mess of time on it. I just thought I'd have one at the very end because it's gonna show you how to divide. So greatest common factor and least common multiple. We're gonna spend a lot of time on this one. Oops, least common multiple. So greatest common factor of 6 I don't know, why don't we do 15? So what's a factor that goes into both? Well, this is 1 times 6 and 2 times 3. This is 1 times 15 and 3 times 5, and that's it. So the greatest common factor here is 3. Now, least common multiples, when do they match? So we have 6, 12, 18, 24, 30, and then we have 15 and 30, and then we have 45. The first time they match is going to be at 30. So find the greatest common factor and least common multiple of 10 and 75. So here we go, 10 and 75. So let's do the factors first. 1 times 10, 2 times 5, that's it. This is 1 times 75, 3 times 25, and 5 times 5 goes into 75. How many times? 1, 15. So they first matches a 5. That's their greatest common factor. And their least common multiple, well, when does 75 and even, so we got 10. 10, the first one's going to be 100. So I'm just going to make these hundreds to see when this one matches. Oh, wait, no, it's going to be, I believe it's 150 because we have 75 and then the next one is 150 and 10 goes into 150. I just don't want to write them all. So I'm pretty sure it's going to be 150. Nice. Nice. Cool. So that was all of them. I hope it was fun. This was everything for multiplication and division. I'm going to be making more. All the other ones are going to be way shorter, besides the algebra, but we're up to here. We're going to do properties of operations next. Then we're going to do mental math and all the rest of them. Then afterwards, you're going to get a quiz on this. So try them, try as many as you like. Hopefully this was useful and enjoy your day.